Now, I've written here the data of the problem just to simplify your memory load. Let's solve the problem. The key thing to notice in this problem is that the monopoly has two choices. So the monopolies can be produce zero, which implies that its profits are zero because it doesn't pay the fixed cost and it doesn't get any revenue or pays any cost of production. Or it can set up the best that it can, conditional on entry. So that's a positive greater than zero. And that is going to do this only if and only if, so set Q1 price, if and only if the profits that it leads to are greater than zero. Okay? Which is it can achieve by producing nothing. That's the key idea of the problem. Now let me solve it for you. Well, we know what it does if it produces zero. Let's look what is the best that it can do if it produces a positive amount. So we know that its total revenue as a function of Q is going to be equal to the inverse demand function of Q times Q. Substituting from this and doing the algebra, this gives us 10A square root of Q. And that implies that the marginal revenue of the monopolies is equal to 5A divided by square root of Q. Now we also know that the best that the monopolies can do, conditional on entry, is given by marginal revenue equals marginal cost. Now the marginal cost is constant and equal to mu, so this is equal to 5A square root of Q. This is equal to mu, and this implies that the quantity of the monopolies, conditional on entry, is equal to 25A squared and divided by mu squared. And also, if you go back and substitute in the inverse demand function, you're going to get that the price of the monopolies, conditional on entry, is going to be equal to 2 mu. Now, given this, we get that the profits of the monopolies in the case of positive production is equal to the quantity that it produces times the price that it gets per unit minus the total cost of production, which are the semi-fixed cost, plus Q monopolies plus times mu. And if you do the algebra, you get that this is equal to 25A squared divided by mu minus the semi-fixed cost. Now, we know that the monopolies produce a positive amount if and only if the profits of the monopolies in that case are greater than zero, and this is greater than zero if and only if the semi-fixed costs are greater than that number. So this is the smallest semi-fixed cost with the quantity of the monopolies greater than zero. That's the answer.